The next thing we're going to fill in will be the angle bisectors. You should also have on your desk a handy dandy protractor. Since I don't have a protractor at home, I had to print out one off the internet. But no fear, they work exactly the same way. To find an angle bisector, you need a line, segment, or ray that bisects each of these angles. Remember, bisect means to make two smaller congruent angles. The way we do that is to find out the measure of each angle and divide it by 2. So put the center of your protractor on the vertex. Line up this dark line and the 0 with this side of your segment. Wherever the other side crosses, mine crosses at about 38 degrees. We need to take 38 degrees and divide it by 2. Half of 38 is 19. So I'm going to come to 19 degrees on my protractor and make a tiny dot. Remove your protractor and make a line that connects that vertex to that dot. What that will make is an angle bisector. And soon we're going to get to the point where we have just a crazy amount of lines on our triangle. So we need to find a way to keep these straight. We know that these are our perpendicular bisectors based on these little right angle signs. We're going to do the same thing for the angle bisectors by filling in our congruent angle marks. Let's give that one 1 each. We need to find the angle bisector of this angle using the same method. Put the center of your protractor on that vertex. Line up the 0 or the dark line with this side of your triangle. Now, since we're measuring from this side, we're going to count up this way. So you need to find where this line crosses over here. Mine crosses at 10, 20, 35, 36, about 36 degrees, almost the same as the other side. That means that I've created pretty much an isosceles triangle. So we know that it should appear somewhere over here, similar to our other side. Half of 36. Can anyone tell me half of 36? Half of 36 is 18. So I'm going to come over 18 degrees and make a small dot. I'm going to connect that dot to this vertex, and by doing so I will have created another angle bisector. let's give this one 2 congruent marks to separate it from this one. We need to make one more angle bisector, this top angle. So again, take your protractor, put the center dot on that vertex. Line up the 0 with one side of your triangle, or that whole dark line. Measure your angle. Now, if yours is clear, you'll be able to see it much better than on this. If you can see this dark line that runs underneath of mine, it's kind of hard to see the bright light, but I'll tell you guys, it's about 52 degrees. Half of 52 degrees is 26 degrees. Come over to 26 degrees and make a small mark. Wait a minute, that's not right. We just flubbed up. Does anyone know where I flubbed up? Somebody tell me. Which angle did we just bisect? The angle we just bisected was this angle. Is that the angle we need? Absolutely not. We need to bisect this entire angle. Let me show you where I made my mistake. When I was lining this up, I'd put my center on that vertex like I was supposed to. I'd lined up this dark line with my segment like I was supposed to. But did I measure my angle correctly? The answer is no. I'd mistakenly used this dark segment as my angle, when in reality I should use this side as the side I measure to. So if we want to correct our mistake, we need to measure from this side all the way around to this side of our triangle. When we do that, we get approximately 104 degrees. Half of 104 will give us 52 degrees. So I need to come over here to 52, which is about right here. Place a small dot. That's more like it. And what will you notice about this small dot and where it lines up? Well, we already have a segment that fills in that need. If we were to connect this anyway, we would see that it's right over top of one of our perpendicular bisectors. That's okay. It just happens to be that way because it's an isosceles triangle. Go ahead and fill in your congruent marks. We will give this one 3. Now what we've just created is our angle bisectors.